Let's now take a look at question number 2. Okay, for question number 2, we have a modeling question for vectors. An archer shoots an arrow towards a target. Okay, in a model, the arrow is a particle. The flight path of the arrow is a straight line. So what we have here, we have a flight path and it is a straight line. Okay, the target is part of a plane. So let's use a different color to draw a plane. So there we go. So here we have a plane. Okay, and therefore this would be the target. There we go. So this is the flight path. Okay, the arrow is fired from the position. Okay, so what we do is, okay, originally the arrow is fired from this point. Okay, 3, -5, and 2. The plane containing the target has the equation. So 2x plus 4y minus z is equal to 3. So what we have, okay, the beginning here we have 3, -5, and 2. The question, okay, A. Determine the shortest distance that the arrow must travel to reach the plane. So shortest distance will always means it's perpendicular. So from here to the plane, so here it will be 90 degree. So this is your shortest distance D. Okay, so let's answer question A. So to answer this one, right, they actually give us the formula in the formula booklet. So what we need to do is rewrite our plane equation. So our plane equation would be 2x plus 4y minus z minus 3 equal to 0. So based on this, our n1 is 2, our n2 is 4, our n3 is -1, and our d is equal to -3. And then the point, okay, the point that we have here is 3, -5, 2, which means alpha is equal to 3, beta is equal to -5, and gamma is equal to 2. Now, to find the distance, we can simply input it into this formula. So, shortest distance is equal to modulus n1 alpha. So 2 multiplied by 3 plus n2 beta, 4 multiplied by -5 plus n3 gamma. So -1 multiplied by 2 and then plus d, which is -3, over square root n1 squared plus n2 squared, which is 4 squared, plus n3 squared, which is -1 squared. Okay, let's just draw the line. There we go. Okay, let's use our calculator to find the values. So here we have 2 times 3 plus 4 times -5 plus -1 times 2 plus -3. So I have modulus -19 over, okay, square root of 2 square plus 4 square plus -1 square. That is square root 21. So it will be equal to 19 over square root 21. Okay, with that, we are done with part A. Let's now take a look at B. Okay, the arrow hits the target at the point 6, -2, and 1. So here we have Okay, so the target here is at 6, -2, and 1. Okay. Determine a vector equation of the flight path of the arrow. Okay, so what we're finding is just the vector. Okay, so in the beginning, we have, what is our OP? The first point, our first point is, OP is 3, -5, and 2. Whereas our OT, from O to the target, we have 6, -2, and 1. We want to find the flight path, so from P to T. So it would be negative OP plus OT. Why is it negative OP? Because we want it to be PO. From P you go to O, and from O you go to T. So this would be equals to -3, -5, 2 plus 6, -2, and 1. So this is equal to -3 plus 6, 5 minus 2, -2 plus 1, which is equal to 3, 3, -1. We are done with B. Next, determine the acute angle that the flight path of the arrow makes with the target. Give your answer to the nearest degree. Just now we find the shortest distance vector equation, and this one is the acute angle between the flight path of the arrow and the target. Okay. So I'll draw a new drawing for this one. Now, let's draw the target. I'm going to draw the target like this. So this is the plane. Oh, let me make it into a line. So this is my target. It is on a plane. Okay. So what happened now? I have a flight path that is a straight line. So let's say it's from P to Q. It looks like P to T. It looks like that. So here is P and here is T. So PT moving it like that. And this is your plane. Now, in plane, right? Plane equation, we have end. What is the definition of end? End means normal. Normal to the plane. That means we have a straight line here. So this is our end. Oops. Okay. So this is our end. Why can't it be straight? Let me just draw it so that it's straight like that. There you go. So this is your end to the plane. Okay. So what we want to do is we want to find, okay, the angle here. This is what we want to find. We want to find X. The angle between the arrow and also the target. But what we have are these two vectors, PT and end. So if we use the angle formula, what we will find is this one, angle Y. So you have to do step by step in order to find X. Let's start by finding X. Oh, let's start by finding Y. So for C, we have, okay, what is our n? Our n is plane 2, 4, -1. So 2, 4, -1. And what is our PT from our previous question? It was 3, 3, -1. And the formula to find the angle would be cos x equal to modulus of this. Okay. Modulus of 2, 4, -1 dot with 3, 3, -1 over, okay, modulus of n, modulus of PT. So what will happen? We're going to do the dot product up here. We will get 2 multiplied by 3 plus 4 multiplied by 3 plus -1 multiplied by -1 over modulus of n. So it will be square root 2 square plus 4 square plus -1 square. And then the second modulus is 3, 3, negative 1. So it will become 3 square plus 3 square plus negative 1 square. Okay, so let's compute one by one. So here we have 2 times 3 plus 4 times 3 plus negative 1 times negative 1, that's just 1. So we got 19 up here over, okay, I believe we already found this one. Okay, square root 2 square plus 4 square plus negative 1 square, that is square root 21 from the previous question. So we only need to find the second one, which is square root 3 square plus 3 square plus negative 1 square, which is square root 19. So x is equal to inverse cos 19 over square root 21 square root 19, which is equal to, okay, oh, they want us to give the answer to the nearest degree, so make sure we change our calculator so that it is in degree mode. So now it will be inverse cos 19 over square root 21 multiplied by square root 19. Okay, close bracket. I will get 17.975 degree. What we want to do is we want to find y. Okay, because this is perpendicular, so y is 90 minus x, which is 90 minus 17.975. So 90 minus answer, we will get 72 degree. That's it. Done with B. Done with C. Moving on to D. Okay, they want us to find the distance traveled by the arrow. So distance traveled by the arrow is basically, okay, so D, distance traveled by arrow is basically is just modulus of PT. We know our PT already. So modulus of that would be 3 square plus 3 square plus negative 1 square, which is, we already compute here, that is square root 19. Done. D is also done. E, comment on whether the actual distance traveled by the arrow is likely, okay, actual distance travel is likely to match the answer to part D, giving a reason to your answer. Okay, let's see for E, right? Okay, it is unlikely to match. Okay, why? Because, okay, in actuality, it is unlikely for the flight path to be a straight line. Okay, that's it for this question. We managed to finish all of this.